Industry 4.0 is a project in the high-tech strategy of the German government, which promotes the computerization of the manufacturing industry. The goal is the intelligent factory, which is characterized by adaptability, resource efficiency and ergonomics, as well as the integration of customers and business partners in business and value processes. Technological bases are cyber-physical systems and the Internet of Things. Experts believe that Industry 4.0 or the Fourth Industrial Revolution could be a reality in about 10 to 20 years. Meanwhile, in the United States, an initiative known as the Smart Manufacturing Leadership Coalition is also working on the future of manufacturing. Smart Manufacturing Leadership Coalition is a non-profit organization of manufacturing practitioners, suppliers, and technology companies. Manufacturing consortia, universities, government agencies and laboratories. The aim of this coalition is to enable stakeholders in the manufacturing industry to form collaborative R&D, implementation and advocacy groups for development of the approaches, standards, platforms and shared infrastructure that facilitate the broad adoption of manufacturing intelligence. Similarly, GE had been working on an initiative called the Industrial Internet. The Industrial Internet aims to bring together the advances of two transformative revolutions, the myriad machines, facilities, fleets and networks that arose from the Industrial Revolution, and the more recent powerful advances in computing, information and communication systems brought to the fore by the Internet revolution. According to GE, together these developments bring together three elements, which embody the essence of the Industrial Internet: intelligent machines, advanced analytics and people at work. Description: the term Industry 4.0 refers to the Fourth Industrial Revolution. The first industrial revolution was the mechanization of production using water and steam power. It was followed by the second industrial revolution, which introduced mass production with the help of electric power, followed by the digital revolution, the use of electronics and IT to further automate production. The term was first used in 2011 at the Hanover Fair. In October 2012, the Working Group on Industry 4.0, chaired by Siegfried Deyes and Kagemann, presented a set of Industry 4.0 implementation recommendations to the German federal government. On April 8, 2013, at the Hanover Fair, the final report of the Working Group Industry 4.0 was presented. Meaning, characteristic for industrial production in an Industry 4.0 environment are the strong customization of products under the conditions of high flexibilized production. The required automation technology is improved by the introduction of methods of self-optimization, self-configuration, self-diagnosis, cognition and intelligent support of workers in their increasingly complex work. The largest project in Industry 4.0 at the present time is the BMBF Leading Edge Cluster Intelligent Technical Systems OST Westfalen-Lippe. Another major project is the BMBF Project RESCOM, as well as the Cluster of Excellence Integrative Production Technology for High-Wage Countries. Industry 4.0, what it means for the future industry. Recently, McKinsey released an interview featuring an expert discussion between executives at Robert Bosch, Siegfried Deyes and Heinz D. Renbach, and McKinsey experts. This interview addressed the prevalence of the Internet of Things in manufacturing and the consequent technology-driven changes that promise to trigger a new industrial revolution. At Bosch, and generally in Germany, this phenomenon is referred to as Industry 4.0. The basic principle of Industry 4.0 is that by connecting machines, workpieces and systems, we are creating intelligent networks along the entire value chain that can control each other autonomously. Some examples for Industry 4.0 are machines that predict failures and trigger maintenance processes autonomously, or self-organized logistics that react to unexpected changes in the production. So, what effects does this change have on the classic manufacturing value chain? According to Siegfried Deyes, it is highly likely that the world of production will become more and more networked until everything is interlinked with everything else. While this sounds like a fair assumption and the driving force behind the Internet of Things, it also means that the complexity of production and supplier networks will grow enormously. Networks and processes have so far been limited to one factory. but in an Industry 4.0 scenario, these boundaries of individual factories will most likely no longer exist. Instead, they will be lifted in order to interconnect multiple factories or even geographical regions. The differences between a today's factory and an Industry 4.0 factory. In current industry environment, providing high-end quality service or product with the least cost is the key to success, and industrial factories are trying to achieve as much performance as possible to increase their profit as well as their reputation. In this way, various data sources are available to provide worthwhile information about different aspects of the factory. In this stage, the utilization of data for understanding the current condition and detect faults and failures is an important topic to research. In production, there are various commercial tools available to provide OEE information to factory management in order to highlight root cause of problems and possible faults in the system. In contrast, in an Industry 4.0 factory, in addition to condition monitoring and fault diagnosis, components and systems are able to gain self-awareness and self-predictiveness, which will provide management with more insight on the status of the factory. Furthermore, peer-to-peer comparison and fusion of health information from various components provides a precise health prediction in component and system levels and enforce factory management to trigger required maintenance at the best possible time to reach just-in-time maintenance and gain near-zero downtime. What are the challenges? Lack of adequate skill sets to expedite the march towards Fourth Industrial Revolution, threat of redundancy of the corporate IT department, general reluctance to change by stakeholders, role of big data and analytics, modern information and communication technologies like cyber-physical systems, big data or cloud computing will help predict the possibility to increase productivity, quality and flexibility within the manufacturing industry and thus to understand advantages within the competition. Big data analytics consists of 6 Cs in the integrated Industry 4.0 and cyber-physical systems environment. 6C system that is consist of connection, cloud, cyber, content context, community, and customization. In this scenario and in order to provide useful insight to the factory management and gain correct content, data has to be processed with advanced tools to generate meaningful information. Considering the presence of visible and invisible issues in an industrial factory, the information generation algorithm has to be capable of detecting and addressing invisible issues such as machine degradation, component wear, etc. in the factory floor. Impact of the Industry 4.0. There are many areas that are foreseen to have an impact with the advent of the Fourth Industrial Revolution, of which 4 key impact areas emerge: machine safety, industry value chain, workers, socio-economic, see also, big data, SCADA, Internet of Things, machine-to-machine, industrial control system, industrial internet, predictive manufacturing system, computer-integrated manufacturing. References. External links: Cloud-based design and manufacturing, Industry 4.0 a Euro-Hightech-Strategie der Bundesregierung, Bundesministerium für Quarter Forschung und Entwicklung, Zukunftsprojekt Industry 4.0, Plattform Industry 4.0, BMBFs Business Cluster Euro Intelligent Technische System Ostwestfalen-Lipitz OWL, Excellenzcluster Integrative Productionstechnik für Quarter Hochlohe Currency in der 1.